Hello students, welcome to the topic differentiability. In my last video I discussed the derivative of inverse trigonometric functions with composite variable and also some algebraic expressions, what is the substitution taken and what identity we get, and also one example on substitution method. In this video I am going to discuss derivatives of inverse trigonometric functions by substitution method. First example, if y is equal to cos inverse 1 minus x square divided by 1 plus x square and x is less than 1 greater than 0, then find dy by dx. Dear students, in this example we have condition here x is less than 1 greater than 0. I explain why this condition is given in the example later after writing some few steps of answer. And here look at the function cos inverse 1 minus x square divided by 1 plus x square. It is a composite function, but variable is some standard expression we have. So therefore this function we differentiate using substitution method. Okay, taking the substitution. For that, first you write given function, then take the substitution x equal to tan theta. Okay, for this expression we have to take x equal to tan theta function. So this implies tan inverse x is equal to theta. Transfer this tan function left side, it becomes inverse function and theta remains as it is. Okay, so therefore what is the y we get? You take this as equation 1. Y we get cos inverse 1 minus tan square theta divided by 1 plus tan square theta. Okay, and this function is nothing but cos 2 theta. 1 minus tan square theta divided by 1 plus tan square theta is equal to cos 2 theta. Remember, these are you proved in inverse trigonometric topic. Remember all these results. Okay, so now using inverse trigonometric properties, this cos inverse of cos 2 theta is written as following this. Cos inverse of cos theta, always it is equal to theta angle, and here we have 2 theta, therefore it is written as y equal to 2 theta. We got simplest, but it is in theta variable, so let me convert into x variable by substituting theta function from equation 1. So therefore from equation 1 y is equal to 2, theta means tan inverse x from equation 1. So this is function simplest form, or this function is equal to this function cos inverse 1 minus x square divided by 1 plus x square, equal only when if this x is less than 1 or greater than 0. If x variable values taken only in this case, only in this between the numbers, then only it is equal. So therefore these in front of examples usually they give these conditions. You don't worry about this condition, so just understand whatever we get simplest form, so that two are equal only if x is belongs to in this range. This given composite function or a complicated form function is equal to this simplest function if x variable is lies between 0 to 1, like that you understand. So that's why this question is given. Don't worry about this condition. Okay, next we got simplest form, then you differentiate with respect to x variable. So dy by dx is equal to, so 2 is multiplied as it is constant number, and tan inverse x, it is 1 divided by 1 plus x square. So this is derivative of the given function. I hope you understood, students. Now go for second example. If y is equal to cos inverse 2x divided by 1 plus x square and x is between -1 to 1, then find dy by dx. Okay, so here also in this example we have standard expression variable, so therefore we find answer using substitution method. First you write given function y is equal to cos inverse 2x divided by 1 plus x square. So what is the substitution taken for this expression? 2x divided by 1 plus x square. For this, x is taken tan theta again. Okay, so here important is expression. You don't see the function, neighborhood function or inverse function. Don't see this one. Expression is important. Already I given for the expression what is the x is taken in my last video. If you don't know, watch it and then you will understand here. This implies tan inverse x is equal to theta. So take this as equation 1. Then for y is become cos inverse 2 tan theta divided by 1 plus tan square theta. So this 2 tan theta divided by 1 plus tan square theta function is nothing but sine 2 theta. Okay, so therefore I change this to sine 2 theta. So using allied angle, see here I'm not going to use now inverse trigonometric property here because cos inverse is there, here sine function is there, here cos inverse sine function opposite or co-function, so we cannot use that property now. So therefore using allied angle, change this sine function to cos form using this formula. Sine theta is written as cos of 90 pi by 2 minus theta. Once again I repeat how to change it. Sine function is taken as cos. When you change sine to cos, you should not take the same angle. Angle is taken pi by 2 minus and same angle, left side angle. Okay, now I follow this one. I will write cos 2 theta is written as pi by 2 minus 2 theta because it is changed to cos. Now I can use a inverse property. It become pi by 2 minus 2 theta. Just now a previous example I discussed how to write it. Directly I will write pi by 2 minus 2 theta. So this is simplest, but it is in theta variable. So from equation 1 you replace theta by tan inverse x. Okay, so from equation 1 theta is substituted. So now this equation I transfer. What we have, y is equal to pi by 2 minus 2 tan inverse x. So this equation I differentiate. dy by dx is equal to pi by 2 constant number, its derivative is 0 minus as it is 2 as it is, tan inverse x derivative is 1 divided by 1 plus x square. So rewriting this function, our answer dy by dx we get. So here 0 is not written, directly minus 2 divided by 1 plus x square. So this is the derivative of the given function. I hope you understood what we have to do it when we have a co-function. Okay, in middle step we got cos inverse of sine 2 theta. No, we changed sine to cos form using allied angle. In the same way you may get different functions. For example, sine inverse cos, in that moment cos is changed to sine using allied angle. Tan inverse cot, cot inverse of tan, like that we get co-functions. Then you should know it what we have to do it. So go for next example. If y is equal to sine inverse 1 minus x square divided by 1 plus x square and x is less than 1 greater than 0, then find dy by dx. Already I discussed what we have to take for this expression substitution and what is the identity we get. So this example try yourself. So write the solution yourself. Let me go for next example, fourth one. If y is equal to tan inverse 3x minus x cube divided by 1 minus 3x square and x is less than 1 by root 3 greater than minus 1 by root 3, then find dy by dx. So first you write given function. Then here also we take the same substitution, because x equal to tan theta. If I take tan theta, this gives a standard identity. So already I given this expression in the last video. So this implies tan inverse x equal to theta. So therefore take this as equation 1. Therefore y is equal to tan inverse. Now I replace 3 tan theta. Wherever x is there, you replace tan theta. Then minus tan cube theta divided by 1 minus 3 tan square theta. So this is a substitution. Next is this function is become tan 3 theta. 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So using a allied angle, we have a same function here, tan inverse and tan. So therefore using identity inverse trigonometric property, this is written as 3 theta. So it is in theta variable, simplest form, but it is theta variable replaced by equation 1 tan inverse x. So I differentiate this equation. Okay, so this we substituted from the equation 1. Now I differentiate this one. Dy by dx equal to 3 as it is. Tan inverse x is 1 upon 1 plus x square. So this is derivative of the given example. I hope you understood substitution and identity here. Okay, next example. If y is equal to tan inverse 2x divided by 1 minus x square, then find dy by dx. Okay, it is a simple expression, 2x divided by 1 minus x square. So first you write tan inverse 2x divided by 1 minus x square given function, and then take the substitution x equal to tan theta. This implies tan inverse x is equal to theta. See what, take this as equation 1. Now y is equal to tan inverse 2 tan theta divided by 1 minus tan square theta. This function is now 2 tan theta divided by 1 minus tan square theta is nothing but tan 2 theta. So it is written as tan 2 theta. See, all these results you proved in inverse trigonometric chapter. Okay, so don't forget all these identities. Now using again inverse trigonometric property, it is written as 2 theta, and from equation 1 theta is substituted as tan inverse x. Okay, because we have to differentiate with respect to x, or dy by dx we have to find out. So differentiate this one, it becomes 2 divided by 1 plus x square. Okay, next example. So this is from the NCERT textbook. All maximum NCERT textbook examples only I considered. If y is equal to secant inverse of 1 divided by 2x square minus 1 and x is less than 1 by root 2 greater than 0, then find dy by dx. So this is also composite function, but variable is standard expressions. Therefore we find dy by dx using substitution. So here look at the function or composite variable, denominator 2x square minus 1. Okay, so we have this expression. Now for this expression the substitution is taken cos theta, x equal to cos theta. Okay, see if I take this one, what we get and what is the identity it become, you will get the idea. Cos inverse x is theta function, and take this as 1. So therefore y is equal to secant inverse 1 divided by, now I replace x by cos theta, it become cos square theta minus 1. Okay, so therefore y is equal to secant inverse, now 2 cos square theta minus 1. So this denominator trigonometric function is nothing but cos 2 theta. Okay, what it is? Cos 2 theta. Next, 1 upon cos 2 theta is nothing but secant 2 theta. We got same function now. So using trigonometric identity, 1 upon cos theta is secant theta. Using that one. Here this is cos 2 theta. In first PUC, you proved these results. See, in this derivative chapter, especially trigonometric functions, very important is identities. You should remember, you should know all the identities. Now, using the inverse trigonometric function property, it is written as only 2 theta, and from equation 1, theta is substituted cos inverse x. Okay, it is theta is cos inverse x. So now I differentiate this function with respect to x. dy by dx is equal to 2 as it is. You know the derivative of cos inverse x. It is minus 1 divided by root of 1 minus x square. So rewriting this function, it become minus 2 divided by root of 1 minus x square. So this is the solution or a derivative of the given example. I hope you understood what is the substitution and identity we get, and then simplest form. Now see the next example. If y is equal to sine inverse 2x into root of 1 minus x square, x is less than 1 by root 2, greater than minus 1 by root 2, then find dy by dx. First you write given function y is equal to sine inverse of 2x root of 1 minus x square. Now look at this expression, students. This is root of 1 minus x square. So in last video I discussed what we have to take substitution if it is root of 1 minus x square expression. So x is taken sine theta or cos theta. So here I will take x equal to cos theta. Then what is the cos inverse x? It is theta. So therefore y, you take this as equation 1. Therefore y is equal to sine inverse of 2 cos theta into root of 1 minus cos square theta. Replace this by x by cos theta function. It becomes cos theta whole square, which is nothing but cos square theta. So next step, y is equal to sine inverse of 2 cos theta as it is, and this is nothing but sine theta. Root of 1 minus cos square theta is sine theta. Now this product is written as sine 2 theta. Okay, so this is compulsory, otherwise you will not get simplest form. So whenever you see the product 2 cos theta sine theta or 2 sine theta cos theta, the product is written as sine 2 theta. Remember students, it is a standard identity, so remember this. Next, so we have same function, so it is a inverse trigonometric property. It is written as 2 theta. From equation 1, it is theta is replaced by cos inverse x, then it is differentiated. So dy by dx is equal to 2 as it is, or minus 2 directly, divided by root of 1 minus x square. So this is solution. Even you can take x equal to sine theta also. So you will get positive answer, that's it. Okay, here you will get sine inverse x. Then here it is 2 divided by root of 1 minus x square. Okay, if you want you can try that one. Okay, I will go for next example. If y is equal to sine inverse of root 1 minus x square, then find dy by dx. It is a simple example. Y is equal to sine inverse of root of 1 minus x square. Just now I explained what we have to take. X equal to cos theta. Cos inverse x is equal to theta. Take this as equation 1. And then function become y is equal to sine inverse of root of 1 minus cos square theta. Y is equal to sine inverse of sine theta. So then it is written as theta. So therefore theta cos inverse x from equation 1. So this function is differentiated. We get dy by dx equal to minus 1 divided by root of 1 minus x square. So this is the solution. So this is very simple example. Okay, we have alternative method for this example. Given function you write. Remember students, this sine inverse of root 1 minus x square function, here you see, when we use a substitution, what is the answer we get? We got cos inverse x. You can substitute directly this function. Remember, these two are very standard functions. Remember, equivalent form. Cos inverse x is nothing but sine inverse x. Sorry, sine inverse of root of 1 minus x square. So these are very important identities to convert sine inverse to cos inverse or cos inverse to sine inverse. Okay, so therefore here I write sine inverse directly in terms of cos inverse x. Actually, we in inverse trigonometric function we have a formula or a result like this. Cos inverse x function, it is equal to, now I change this cos inverse to sine inverse, no, then x angle we have to change it root of 1 minus x square, or using a triangle method also we can, if I write a cos inverse function in terms of sine inverse equivalent, we get like this, sine inverse of root 1 minus x square. So therefore these two are equal, you can substitute directly. So now then you can write differentiation of this function directly, minus 1 divided by root of 1 minus x square. Same answer we got. So this is a for more number of marks, and this is 1 mark or 2 mark you will get. Direct substitution 1 mark, differentiation 1 mark. Here substitution, getting simplest form, and then derivative 3 marks, or sometimes 2 marks. I hope you understood. So just you understand here, direct we can substitute, and remember these two functions. Cos inverse x is written as sine inverse root of 1 minus x square, like that it is written. Okay, next example. If y is equal to sine inverse x plus sine inverse root of 1 minus x square, x is less than 1 greater than 0, then find dy by dx. Okay, so this example we can write in two ways. One is you know that what is the sine inverse of root of 1 minus x square, just now I explained. No need of taking substitution method, no need of taking substitution. Directly you can write this as a cos inverse x. Sine inverse x derivative, you know, write it. Cos inverse x derivative, you know, write it. Then what we get, then see that one and find out the dy by dx. Otherwise, here we can use one identity. Let me first substitute. Sine inverse means cos inverse x. In inverse trigonometric chapter, you proved that sine inverse x plus cos inverse x, we have same x and sine inverse and cos inverse. So therefore, so this function is nothing but, using identity we can write pi by 2, constant function pi by 2. Okay, we have, you proved this one in inverse trigonometric chapter. Sine inverse x plus cos inverse x is pi by 2. Now I differentiate this one because it's the simplest term, its value is 0. Okay, suppose if you not use identity here pi by 2, sine inverse x derivative, you write it, directly differentiate the equation. It is 1 upon root 1 minus x square. Cos inverse x function derivative is minus 1 divided by root of 1 minus x square. So plus 1 upon root 1 minus x square minus 1 divided by root of 1 minus x square, both cancel, you will get 0 answer. Same. Otherwise, use identity, then you differentiate. I hope you understood, students. Go for next example. If y is equal to tan inverse of sin x divided by 1 plus cos x. Now the example is not substituting x equal to function. We have some trigonometric identities. Substituting that trigonometric identities, we get a simplest form. Then we differentiate the function. So such type of examples now. Then find dy by dx. Okay, first you write given function. Okay, look here. First I explain what is a sin x function. So sin x function and 1 upon cos 1 divided by 1 plus cos x. You remember this combination, because this identity, these functions are very important in integral chapter, because most of the examples we use for this combination we use identity. So identities are like this. Sin x is written as, look here, sin x function is written as 2 sin x by 2 into cos of x by 2, and 1 plus cos x function is written as 2 cos square x by 2. Okay, so remember these two functions substitution. And one more is there, 1 minus cos x, 1 plus cos x. This is 1 minus, if we have, then 2 sin square x by 2 is written. Okay, I explaining 1 minus cos x function substitution, 2 sin square x by 2. So if we have this combination, sin x divided by 1 plus cos x, sin x divided by 1 minus cos x, or 1 plus cos x divided by 1 minus cos x, if you have this combination function, use this identity and you will get a simplest form. Okay, now I replace sin x means 2 sin x by 2 into cos x by 2 divided by, and 1 plus cos x function is written as 2 cos square x by 2. I hope you got it, identity as well as how to simplify. So here 2 and 2 get cancelled, and 1 cos function get cancelled. So what we get, sin x by 2 divided by cos x by 2, and this can be written as tan x by 2. So here we got same function, tan inverse and tan, so therefore it is written as x by 2 using properties. Now I differentiate, this is directly in terms of x variable, I differentiate this equation. So dy by dx is equal to, see here x by 2 means 1 upon 2 into x. So 1 upon 2 is a constant. So therefore 1 upon 2 as it is, and x derivative is 1. So if I simplify this, once again rewriting, dy by dx is equal to 1 by 2 into 1 means it is 1 by 2. So this is the derivative answer. I hope you understood substitution, what we have to take for sin x, and 1 plus cos x function equivalent, and after substituting what we get. Thank you, students.